Welcome back, everybody, for another deep dive. This time, we're going to be tackling something well, it's pretty fundamental in the
Hmm.
world of software design,
Yeah.
but it's also surprisingly controversial,
Right.
and that's the Singleton pattern.
Yeah.
And for this one, you guys sent over a really interesting collection of sources. We've
Yeah.
got an excerpt from a design patterns book,
Hmm.
a study guide,
Yep.
and even
Oh,
a
we checking?
YouTube
A
tutorial
YouTube tutorial. Yeah, that's a good one.
that gets hands-on with Scrabble, of all things.
It really does. And it's really cool how he uses that to illustrate the singleton pattern.
So before we jump into all of that,
Yeah.
can you just give us a little bit of background for anyone who's not familiar with design patterns in general? Like, what are we even talking about?
Yeah, absolutely. So design patterns at their core are like reusable blueprints for solving common problems in software. They provide a starting point, a way to structure your code so you don't have to reinvent the wheel every time.
Okay, so like, kind of like templates for tackling recurring challenges.
Exactly. Yeah, like having a set of best practices or proven solutions that you can adapt to your specific needs.
Okay, so what makes this Singleton so special? Like, what's the problem that it solves that gets everyone all riled up?
Well, imagine you're building an app and there's this crucial component that needs to be accessed from all over the place,
Okay,
like a database connection or a configuration settings manager.
gotcha.
You don't want multiple parts of your code creating their own versions of this component, because then you could have conflicts or inconsistencies.
Right, right, that makes sense. So you want one central authority, one single source of truth. Is that where the Singleton comes in?
Exactly. The singleton pattern guarantees that a class has only one instance and provides a global access point to that instance. It's like having a single, well-defined entrance to a building, ensuring everyone goes through the same door.
Okay, so we've got the what, but I'm curious about the why.
Mhm.
Uh, the excerpts mentioned that Singleton solved two specific problems. Can you unpack those for me?
Absolutely. So first, as we touched on, it helps manage access to shared resources.
Right.
Think of a database connection. You don't want multiple parts of your application opening and closing connections haphazardly. That can be inefficient and lead to resource contention. A singleton acts like a gatekeeper, ensuring a single controlled connection is used throughout the application.
Okay, so it's like a shared pool of taxis instead of everyone calling their own.
Yeah.
Efficient, avoids a traffic jam.
Yeah, exactly.
What's the second problem it addresses?
The second issue is related to global variables. They're easily accessible, but also prone to accidental overwrites or modifications, which can lead to bugs that are hard to track down.
Ah, global variables, the temptress of coding. Easy to use, but can cause all sorts of chaos if not handled carefully. So how does a Singleton avoid those pitfalls?
A singleton offers a way to control access to a single instance without resorting to those risky global variables. It's like having a designated storage area for important data, with clear rules about who can access and modify it.
Okay, starting to see the appeal here. You get global access without the global variable headaches. But how does this Singleton magic actually work in code? The study guide and that YouTube tutorial both mention some key elements.
Yeah, so the core mechanism is actually surprisingly elegant.
Okay.
First, you make the class's constructor private. This prevents anyone outside the class from creating new instances directly using the new keyword.
So it's like putting up a do not enter sign on the construction site.
Right.
Only authorized personnel allowed.
Precisely. Then you create a special static method, usually called getInstance, which acts as the gatekeeper.
Right, the getInstance method. The study guide called this lazy initialization. What does that mean exactly?
So it means that the singleton instance is only created when it's actually needed. So the first time getInstance is called, it creates the instance and stores it, and then every subsequent call simply returns that same instance, ensuring there's only one in existence. It's a way to optimize resource usage, only creating the instance when absolutely necessary.
Oh, that's clever. Like turning on the lights only when someone enters the room. Saves energy. The YouTube video really brought this to life with the Scrabble example. He showed how multiple attempts to create a new instance actually resulted in the same object underneath.
Yeah, it's a great illustration.
Yeah.
He even used the system identity hash code to prove that they were referring to the same object in memory. But there's a catch, as the video also highlighted. What happens when multiple threads try to access the singleton concurrently?
You mentioned threads earlier. Can you just remind me what those are in this context?
So imagine you have a multi-threaded application. where different parts of the code are executing simultaneously, like players in a multiplayer game.
Okay.
Each thread represents a separate flow of execution.
Okay, so multiple things happening at the same time. What's the problem with that in relation to singletons?
Well, if two threads try to create the singleton instance at the same time, you could end up with two instances, which breaks the whole point of the pattern. The video demonstrated this beautifully with the Scrabble example, showing how two threads accessing the singleton letter bag led to separate instances and caused chaos in the game.
Oh, yikes. That does sound like a recipe for disaster.
Right.
It's like two chefs trying to cook in the same kitchen at the same time, but with only one set of ingredients.
Exactly.
So how do you prevent this singleton meltdown from happening in a multi-threaded environment?
That's where things get a bit more technical.
Okay.
There are a couple of common approaches, each with its own trade-offs.
Right.
The first is to use the synchronize keyword,
Mm-hmm.
essentially forcing threads to take turns, accessing the getInstance method, preventing those simultaneous creation attempts.
So it's like installing a traffic light at that single entrance we talked about earlier. Only one thread can go through at a time, ensures order. But I imagine that could slow things down, right?
You're right. Using synchronized can introduce some performance overhead,
Yeah.
especially if there's a lot of contention for that singleton instance. That's why the video presented a more efficient solution, synchronizing only during the initial instance creation.
Oh.
Once the instance exists, no more synchronization is needed,
Gotcha.
like removing the traffic light once everyone's safely inside the building.
Ah, that makes sense. You only need that extra control during that critical setup phase.
Right.
For our listener who might not be a coding whiz, is it more important to understand how this works under the hood, or simply that thread safety is something that needs to be addressed?
I think the key takeaway here is awareness.
Okay.
Understanding that concurrency, multiple things happening at once, can create unexpected issues with something like a singleton. Even if you're not writing the code yourself, being aware of these potential pitfalls can help you ask the right questions and evaluate solutions more effectively.
So it's about being an informed consumer of technology, recognizing that even seemingly simple patterns like the singleton have hidden depths and complexities.
Exactly.
Now, I remember you mentioned earlier that the singleton pattern is a bit controversial.
Yeah.
Why is that?
Well, like any powerful tool, a singleton can be misused or even mask underlying design flaws.
Okay.
It's not a one-size-fits-all solution.
So when is a singleton a good fit? And
Well-
when might it be a red flag? The sources hinted at some potential downsides.
One issue is that singletons can violate the single responsibility principle, which states that a class should have one and only one reason to change.
Right, the idea that every component should have a clear and focused purpose.
Right, but a singleton often ends up doing two things. Managing the single instance A and D, providing global access to it.
Okay.
This blurring of responsibilities can make the code harder to maintain and modify down the line.
It's like asking your accountant to also handle marketing. They might be good at both, but it's not ideal.
Exactly.
Spreading their focus too thin.
Exactly, and because singletons are so tightly integrated into the application, they can be challenging to mock during unit testing, making it harder to isolate and test different parts of the code.
Mocking, that's where you substitute a real component with a simulated one during testing, right?
Precisely, and with a singleton, it's difficult to do that cleanly because of its unique nature.
Okay.
You can't easily create alternative instances or control its behavior during testing.
So even for someone not directly involved in coding, understanding these limitations can help them ask better questions and evaluate solutions. It's about seeing the bigger picture, the trade-offs involved in different design choices.
Absolutely. Now, the sources also mention that there are often alternative patterns that might be more suitable than a singleton, depending on the situation.
Ah, so it's not just about whether a singleton is good or bad, but rather understanding its strengths and weaknesses and considering the alternatives. What are some of those alternatives?
One common alternative is dependency injection, where instead of a class managing its own dependencies, those dependencies are provided from an external source.
So instead of the class reaching out and grabbing what it needs, it's given what it needs. Kind of like room service instead of having to go down to the retail restaurant.
A great analogy.
Yeah.
Dependency injection can lead to more modular and testable code because it decouples components, making them less reliant on each other.
Okay, so it's about choosing the right tool for the job. Sometimes a singleton is the perfect fit, but other times dependency injection might be a better approach.
Right.
And even for someone who's not a developer, understanding these high-level concepts can help them engage in more informed conversations about software design.
That's exactly right. It's about empowering people to understand the technology they interact with on a deeper level.
So let's do a quick recap of what we've covered so far on this singleton journey.
Okay.
We started by defining what a singleton is, a pattern that ensures a class has only one instance and provides a global access point.
We then explored why singletons are useful, highlighting their ability to manage access to shared resources, like a database connection, and avoid the pitfalls of global variables.
We delved into the mechanics of how a singleton is implemented, with its private constructor and the getInstance method, which employs lazy initialization to create the instance only when it's first needed.
We then tackled the tricky issue of thread safety, discussing how concurrency can lead to multiple singleton instances being created, and exploring solutions like using synchronized or synchronizing only during initial creation.
And finally, we had that friend or foe debate, recognizing that singletons have both strengths and weaknesses.
We highlighted how singletons can sometimes violate the single responsibility principle and create challenges for unit testing, and we introduced dependency injection as a potential alternative pattern to consider.
Phew, that was quite a ride.
I know, right?
But I feel like we barely scratched the surface of this fascinating topic. What are some final thoughts you'd like to leave our listener with?
Yeah, it's true.
We went from Singleton 101 to a graduate seminar in just a few minutes.
It really is, but I think that speaks to how much depth there is to this seemingly simple pattern.
Right.
You know, at the surface, it seems straightforward, but when you start digging deeper, you realize there's all these intricacies and nuances to consider.
Yeah. And our listener might be thinking, okay, this is all fascinating, but like, I'm not building software every day.
Yeah.
How does this singleton knowledge actually benefit me?
Well, I think even if you're not writing code yourself, understanding design patterns like this helps you become a more informed consumer and evaluator of technology.
Okay.
You start to recognize these patterns in the software that you use every day, and you can ask more insightful questions when you're discussing technical solutions or, making decisions about the technology that you want to use.
So it's about being able to see the structure beneath the surface, the decisions that went into creating the software we interact with. It's like appreciating the architecture of a building, even if you're not an architect yourself.
Exactly, and that awareness can empower you to make more informed decisions.
Right.
About the technology that you use, the products that you buy, the systems you rely on.
That's a great point. Demystifying the world of software.
Yeah.
Empowering people to engage with it on a more meaningful level. So what should our listener do with this newfound singleton knowledge?
Well, the next time they encounter a piece of software that uses a singleton, or any design pattern for that matter, they can start asking those why questions.
Oh.
Like, why was this pattern chosen? What are the trade-offs? Are there any potential downsides? Really start digging deeper and understanding the rationale behind those design choices.
Right. It's about not taking things at face value.
Boy.
Like, dig a little deeper.
Exactly.
And understand, like you said, the why behind the design.
Yeah, don't be afraid to challenge assumptions, too.
Oh, that's a good point.
Sometimes the best solutions come from questioning the status quo and exploring those alternative approaches.
Yeah, I love that. Encouraging our listener to become an active participant
Yeah.
in the world of technology, not just a passive consumer.
Exactly.
And who knows, maybe this deep dive will inspire them to learn even more about software design.
You never know.
Or even try their hand at coding themselves.
That would be awesome.
Right.
Yeah.
So what are some final thoughts you want to leave our listener with? This has been a really fun discussion.
The world of software is so vast and constantly evolving, and there's always something new to discover.
Right.
The singleton pattern is just one small piece of the puzzle, but it's a great example of how exploring these fundamental concepts can unlock a deeper understanding of the technology that shapes our lives.
So true. So to our listener out there, keep exploring, keep asking questions, and never stop learning. And if you enjoyed this deep dive and you have other sources you'd like us to unpack, you know where to find us. Until next time, happy learning.